Welcome back to this lecture series on deep learning. In this lecture, we will discuss about the types of recurrent neural network. In the previous lecture, we have seen the introduction about the RNN, recurrent neural network. Just we will see the overview of this RNN. This recurrent neural networks or a class of neural networks, all we know that it is a class of neural networks designed to process sequential data. This will be is to process the sequential data. And the recurrent neural networks are specifically developed to handle data where the order of inputs matters. How many inputs we are going to give, it depends on the output, that is inputs in this recurrent neural network. Unlike traditional neural networks, the RNN can process sequential data such as sequences such as text, speech, or time series data by considering the temporal relationship between the elements. They have the feedback, this RNNs have the feedback connections which allow information from previous time steps to influence the current output. And RNNs contain feedback loops that pass information from one time step to the next time. Next, this mechanism enables the network to retain past information and use it to influence the current output and providing a form of memory that this will be providing the memory form of the memory. And RNNs widely used in applications such as speech recognition, speech translation, language modeling, machine translation, and time series predictions. Due to their ability to learn sequential patterns, RNNs are commonly applied in speech recognition system. Mainly it is used in the speech recognition system and the natural language processing tasks, machine translation, and forecasting problems involving the time series data. Next, based on the input and output relationship, RNN can be classified into that is various different types that we'll see one by one, and it is according to categorized according to how inputs and outputs are mapped across the time steps. This classification helps in selecting the appropriate model for specific sequence based task. We'll see one by. This is the types of RNNs. Here we will see the four types: one to one, one to many to one, and many to many. Means one input, one output, one input, many outputs. Here many inputs, inputs and one output, and many inputs and many outputs. We'll see one by one. First, we'll see one to one RNN, one to one recurrent neural networks. This is the one to one recurrent neural networks. One input is mapped to one output. So in this case, one input is mapped into one output. In a one-to-one RNN, a single input is processed to produce a single output with no involvement of sequence or time dependency here. In this case, this structure does not rely on previous inputs or outputs, making it free from temporal dependencies. And also, the one-to-one RNN behaves like a conventional feed-forward neural networks. So, one input, one output. If suppose if I am giving 5 inputs, 5 output, like that, it will be acting like a just like that an ordinary feed-forward neural network, as it does not utilize its recurrent nature, and it is mainly used in image classification and regression problem. This model is suitable for tasks where both input and output sizes are fixed, such as image classification and regression analysis. The next type is the one-to-many recurrent neural network. Here, the single input, many output. In this case, in a one-to-many RNN, one input is provided initially and the network generates the sequence of outputs across the time steps. Next, the hidden states. The second point is the hidden states of the RNN stores information that allows it to generate outputs sequentially from the same input, And here the output depends on the previous hidden states. That means each output is influenced by the previous hidden state, ensuring continuity and coherence in the generated sequence. And it is mainly used in image captioning, music generation. This means this structure is commonly used in applications where a single input must produce a sequence, such as generating captions of images, captions for the images, or composing music. The next type is the many to one. This is the many to one. In this case, multiple inputs are processed sequentially. That means in many to one RNN, a sequence of input is fed into network at a time in a chronological order, and find the output represents the final output represents the entire input sequence. This means the output is produced only after the entire input sequence is processed, and summarizing all the information. Earlier input influence the final decision. That means fast input past inputs contribute to the hidden states and influence the final output, making the decision context aware. The mainly used in the sentiment analysis and the spam detection. This architecture is widely used in this architecture is widely used in the text classification and the such as sentiment analysis and spam detection. The next type is the many to many RNN. So if you are looking into this diagram, many input, many output. Here we have used various RNNs, many to many, and here each input produces a corresponding output. Input and output sequences has the different lengths. Suppose if you have the same length, here we have the varieties of if the many to many, if the input length is same, input and output lengths are same, each input produces a corresponding output. In this model, every input element in the sequence has the corresponding output element. The second point is input and output sequences are equal length. That means the number of output matches the number of inputs, maintaining the one-to-one alignment across the time steps. And RNN produces the data each, that is produces data step by step in one time. This RNN process each input sequentially and generates the output at every time step. They mainly used in the post tagging and the sequence labeling. This type is commonly applied in linguistic tasks such as part of speech. POS means what? Part of speech. POS means part of speech tagging and the sequence labeling. If suppose the another case many to many RNN, if it is having the different length, input size is different from the output size, how to lag? Input output sequences have the different lengths. That means in this structure, the input sequence length does not match the output sequence length, offering flexibility. That is dynamic changes we can do it. Encoder compresses input sequence into context. That means the encoder processes the entire input sequence and converts it into a fixed length context vector. And the decoder generates output sequence from the context. The decoder uses the context vector to generate the output sequence step by step. And the mainly used in the machine translation and the text summarization. This architecture is extensively used in machine translation and the text summarization tasks. Finally, coming into the summary, first one to one. That means single input, single output. All you know that this structure maps and one input directly to one output and is suitable for non-sequential tasks. Next one is one to many means single input, sequence of outputs. A single input generates the sequence of output using the RNN's memory. And the third type is a sequence here many to one sequence of inputs the inputs to single outputs, many to one. Sequence of input is summarized into single output. Many to many means a sequence of inputs, that is sequence of outputs. This structure maps input sequence into output sequences, either the same or different length, as we have seen it in the previous slide. And finally, The choice of RNN type depends on the nature of the problem and data sequence. That means based on the application only we are going to select it. Selecting the appropriate RNN architecture depends on whether the task involves a single or multiple inputs and outputs over time. So from this, what we are finally saying is based on the application only we are going to select whether the RNN structure would be a one-to-one or one-to-many or many-to-one or many-to-many. Based on the applications only we are going to select it. Hope the basic concepts of types of RNN how everyone understood. The remaining things we'll discuss in the next lecture. Thank you.